Welcome to DevOps for SysOps Part 4, Introduction to Terraform. All right, DevOps is a lot. And I always start out these sessions with this slide. It's meant to scare you. It's meant to have you stop in your feet and just say, what the heck is all of this? This is a lot. Don't worry. That's why we have this series. Part 1, we talked about Git. Part 2, we talked about configuration as code, CAC. Part 3, we talked about Ansible, a specific tool and platform for configuration as code. Today, it's Terraform, infrastructure as code. So we went from that big chaotic slide and zoomed in on a portion of it. Here I filtered out everything that just is created by HashiCorp. HashiCorp is the parent company of Terraform, and they have a couple of other products. Packer, Nomad, Console, Vault, Boundary. These are awesome tools that I could do a presentation all on their own. But today we're just going to talk about Terraform. So what is HashiCorp Terraform? Well, remember configuration as code? Now we're talking about infrastructure as code, or IAC. It's a subset of configuration as code with a focus. And that focus is that it's going to be a tool for IAC. It's meant to define and deploy digital infrastructure, mostly. What's digital infrastructure? It's mostly cloud services, right? So digital, right? Not physical. So what are these cloud services? VMs, Kubernetes clusters, serverless databases, serverless functions, all the kind of stuff that you find in AWS, Azure, or GCP. But also, you can configure your SaaS apps with Terraform as well. I'll have a section on that later. But examples of SaaS apps, GitLab, Vault, and HCP Terraform Cloud. This is the Terraform SaaS solution. And we'll talk a little bit more about GitLab and HCP Terraform Cloud later. Vault is something I want you guys to remember because although this presentation is not about Vault, Vault is a product that also created by HashiCorp that I'll probably do a future session on. It's just that good. It's all about secrets management. So Terraform, what is the structure of it? What's a little bit behind the scenes that makes Terraform? Well, first off, where do we run it? Right? How do we use this tool? Well, you can start on your local desktop with a command line interface. This is kind of what you get. This is actually how a lot of people prefer to run it. But the CLI can be a little bit intimidating. You can also run it on a centralized server, right? So we have that SaaS application, right? That gives you a GUI, right? This is a screenshot of HCP Terraform, right? Formerly known as Terraform Cloud, right? So you can see a couple things in here. You can see my runs, right? These are kind of like CI pipelines, right? So we also have free versus paid version, right? So the CLI, that's the free version. It's good for single users. But you're on your own. You kind of have to figure it out. The SaaS hosted Terraform solution, you get that GUI interface. It's good for teams. I increasingly I like it just on my own. Just the ability to expand and collapse everything in your Terraform plan, which I'll speak a little bit more to later. I should say to expand and collapse your resources, because oftentimes you're creating a lot of resources, and just being able to sort of, quickly expand or truncate those and get them all in one visual field. It's really nice. So you get that GUI. You also get rapid environment creation. You get things like variable sets. You get your runs, which are automation. You get something that they call Sentinel or policy as code governance. And you get remote state management. And then ephemeral resources. This is another topic I'm probably going to want to do an entire presentation on. Ephemeral resources. Um, Vault has a really good example of one of these. Ephemeral tokens, right? As passwords are getting phased out, possibly, right? Maybe quantum is getting us scared about how do we deal with encryption. Well, you have things that don't actually last forever, right? So you can't hack what was in the past. Um, but that is another topic for another day. But something to think about for the future of the DevOps world is ephemeral resources, and HashiCorp is definitely, pushing the future on that. All right, components of Terraform. Well, you have the Terraform CLI, and you have commands like init, plan, apply. This is the standard workflow. So whenever you're getting started with Terraform, you'll run Terraform init, which will uh, look for files that you have in that workspace. It'll download updates to whatever you've kind of specified to use. You'll do a Terraform plan. Okay. A Terraform plan um, looks at your configurations, and it's like a dry run of, oh, I'm going to create, update, or delete these resources. And then apply is about actually deploying those uh, to wherever you're deploying it to, whatever cloud. Configuration files. So we define our resources. And maybe I'll just pause and say, if it's not clear what a resource is, right? A resource, um, as I tried to mention earlier, right? These are really any of the services in your cloud environment, right? So it's a VM, it's a database, it's a serverless function, really whatever is available in your cloud service. Uh, your cloud provider, if we're talking about AWS, GCP, or Azure, or when I say your cloud service, because I'm ta sometimes talking about a SaaS app, right? Like GitLab or actually Terraform Cloud, HCP Terraform as it's called now. So you'll define your so with a configuration file, you'll define your resources or your variables, etc., with .tf files, and these are written in something that's not too dissimilar from YAML, like we've talked about in previous topics, but it's called HashiCorp Configuration Language, HCL. So it's their own proprietary thing. Shouldn't say proprietary. They've been open source enough that uh, there's other competitors like OpenTofu that have forked Terraform. Um, but HCL, that's what it stands for. HashiCorp Configuration Language. Don't worry about it. It's not too closed off if you're scared about proprietary stuff. State file. So this is the file used as a source of truth to track and manage your infrastructure. So in our previous talk, we talked about Ansible being idempotent, right? This is a fancy word for meaning that you could run that script over and over and over again, and it was only going to make changes to things that needed to be changed. So if it had already made a change, it wasn't going to try the same thing twice. That's what our state files are, right? Ansible has a state file. Terraforms are a little bit more uh, rigid and easier to see. Um, it's the source of truth. So it's really easy to see, oh, this resource exists, this resource doesn't exist, this resource has this configuration, or it doesn't, right? So all of that data is stored locally in a terraform.state file, right? This is usually written in JSON or something like that, and it's basically just key values. Um, However, remote state is recommended for collaboration, right? There's a lot of reasons why you don't want to rely on a local TF state file, right? Disaster recovery. Checking it into source code can also be a big security risk. Um, uh, because whatever those values are, you're saving them in a readable file, and then if you're putting it up in GitLab or GitHub, right, other people could possibly see it. So having it in a secure location in a remote state makes it more accessible to people, and it also secures it from obscures it, I should say, from prying eyes. Modules. What's a Terraform module? It's just like in any other programming language, right? It's reusable, self-contained package of Terraform configurations, right? Of Terraform code. Workspaces. Think about this like, how do you manage multiple states, right? Uh, for a single configuration, right? So um, when I say multiple states for a single configuration, maybe think about it like this. Well, I have a development environment, but then I also want to create another environment, like a staging environment and a production environment. Well, each one of those environments need a different Terraform state, even if their configurations are basically identical to each other. Um, so yeah, like I said, you'll use this for environments like development, staging, and production. All right, take a breather. I know I've pounded a lot of information here, and I apologize about that. But we are talking about Terraform, which is a programming language, so it's it's code heavy, and we have to get the basics in. All right, so Terraform files. Well, start in your project folder, your working directory. When you hit Terraform init, right, when you type that in, the first thing that's going to be created is a .terraform hidden file, hidden folder. You'll have your TF state file in here, as well as a number of other uh, files that are just used for the backend functionality of Terraform. This is really where the meat and potatoes is. Your main.tf file. So you'll put all of your resources, data sources, modules, providers, whatever in here. You could actually put everything into one main.tf file, or you could have 12 different .tf files. When you run your Terraform at the end of the day, it's all from its perspective. It's just gonna smash it into one file and read it that way. It's not a scripting language, right? It's just a configuration language. So it's not reading one file top to bottom. Um, it's reading all the files at the same time, all the .tf files. So even though you could smash everything into a main.tf file, I really recommend having a variables.tf file, right? This just keeps your variables separated, right? And a versions.tf file, right? So there's many different versions that you can select as we talk about leveraging Terraform for different providers. Okay, and what are providers? Well, a provider is think of it as like the plugin that's created for Terraform for AWS or for GCP, Azure, or GitLab. So it's basically the Terraform library that you can download and use in order to manage that resource with Terraform. All right. Now we're going to get into the examples. So some of this might look familiar because I did use these first couple of examples in our first configuration as code presentation. But I'm going to go into further detail because we're talking about the code specifically this time. So to create a VM in Terraform, it looks something like this. You basically just need this code block, right? You're going to state what your resource is. an AWS instance in this case. You're going to give it a name. How many do you want to create? Oh, in this case, just one. Specify uh, your virtual machine image. In this case, it's an Amazon Linux 2 image. Your instance type, and then some networking information. And you also specify your tags. In this case, you can see there's a little bit of a hint of where we're going, right? Notice I have a name here that's being augmented with count.index plus 1. So yeah, what about multiple VMs? Well, you just update that count from 1 to 3. And let's see what that looks like. We've created now 3 VMs, test VM 1, 2, and 3. And they're all the same, and they have all the same tags. Okay, so let's take it another step further. So multi-env, multi-environment, different configurations. How are we going to do that with Terraform? So we're going to make it a little bit more complex. Now we're going to talk about how to create 3 VMs in one file. So we have our resource. The most truncate, you could, by the way, you could just have 3 different resource blocks with different configurations, all right? But I'm trying to be concise and fancy here. So this is about as complex as it's going to get. So you'll have a for loop type of thing, right? Now, rather than hard coding these values like I did last time, notice that I have a each.value config, right? For the AMI, for the instance type, and for the networking information, and even the tags. Well, you saw down below that I tags uses this tags equals merge locals.tags, right? So now we're going to talk a little bit about locals, okay? I actually really like this term here. It says instance configs equals flatten. Remember how I talked about Terraform? Uh, it's not a scripting language. It takes all your TF files and reads them together at once. I like to think of that as sort of flattening them. But this is used technically for a different concept, right? It's taking these config values that we have in various places and it's flattening them together in one object, basically. Uh, so this is saying, hey, for your environment and your configs in var.environment configurations, right? Set these values, right? Where's that var.environment configurations? Well, we were here in a main.tf file. Now let's look at our variables file, variables.tf. I'm sure that that's hard to read. Don't worry. Let's zoom in. Let's zoom in a little bit more than that. I've highlighted it, but I promise you, I'm not going to make you read this little font. Uh, I I just want to assure you guys that I hate going to presentations uh, that just put code up on the screen. Unfortunately, in this one, because we're talking about a coding language, I can't get around it. Um, but I'm trying my best. I appreciate your feedback at the end of this. So just want to highlight that we have 3 different configurations here. We have dev, test, and production, color-coded. Okay, now that we're zooming in to the file, right? We're in our variables.tf file. Here's environment configurations, okay? Type map object. Okay, so now we're creating an object that has all of these values in it. Instance type, AMI, subnet ID. And if we scroll down for our dev environment, now we have these things written out. Oh, okay. So these are the configurations for a development instance. And these are the configurations for a test instance. And these are the configurations for a prod instance. So now that we've run our Terraform apply, we'll hop over to AWS and see what that looks like. Here we have our dev instances created with a T2 micro. Production is using a T2 small, which is actually a little bit bigger. And test is using a .T2 nano. All right. So what's beyond multi-environment? Multi-cloud. Multi-cloud. I want to pause here and just talk about why multi-cloud is important for those who haven't gotten quite that far yet. Well, if we check in the news recently, AWS had some hiccups. Uh, yes, AWS is mostly up 99.99% uptime. All of these services pretty much are. But it's inevitable that something will happen. And there's other reasons, not just uptime, to have your important information living in multiple locations, right? It's just classic, don't put all your eggs into one basket. So, uh, in my experience, I was interested in multi-cloud prior to 2020, but after 2020, uh, everyone kind of got serious about it and said, we really need to make this effort. Um, some companies much better than others, um, but it is it is imperative that we start thinking about in the DevOps world. No, sorry, not start thinking about. It's imperative in the DevOps world that we build in a strategy for multi-cloud. At the very least, hybrid cloud. Um, in order to repatriate uh, uh, everything that's important to our company, I think hybrid cloud is very important. Um, as many companies sometimes find themselves in direct competition with AWS, right? That wants to do everything. And for that matter, to be fair, Azure or Google Cloud, right? Um, it makes sense to say, hey, geez, I have all of my company's data up on this cloud service, who I thought was a neutral party, but you know, they're trying to do everything now, and now they're doing my business. Um, so yeah, naturally, you would maybe want to be able to switch, right? Avoid that vendor lock-in, and not feel hostage. So, multi-cloud. How do we do multi-cloud with Terraform? It's pretty simple. All you need are these providers. Okay, these providers, remember I told you that these were plugins, right? You can find these on the Terraform website, very easy. And it's very, actually, I got to speak to this. I love going to the Terraform website. It's so easy to go through their documentation on all of these providers. That's probably one of the reasons why they are so popular is because they made it easy for people to adopt. So this is what a provider looks like. You just state the source and the version number. Uh, I forget what this is called. It's like a twiggle or a swiggle. Um, it doesn't mean greater than 5.0. It means, uh, it actually means greater than or equal to 5.0, but less than 6.0. Um, so sometimes major changes happen on the next version up. So that's a cool thing that Terraform uses quite a bit. Um, because yeah, we want to in DevOps we want to be um, we want continuous deployment, but realistically not until we're ready. So sometimes we have to slow things down deliberately to say, I'm not ready for the new version yet, right? But I want to be as up to date as possible. Frankly, it's probably smarter to use a greater than or equal than in conjunction with a less than or equal to version number because many times we know exactly when um, these breaking changes come out. But anyway, back to providers, back to multi-cloud. So here we have three providers for AWS, Azure, and GCP. Let's dig in and see a little bit more of what that looks like when we want to create a VM. So in AWS, it can be as simple as just stating your AMI and your instance type. Uh, the provider for AWS is very, very robust. AWS, I should say all of these companies that I'm mentioning, AWS, Azure, GCP, they have full-time staff that are developing these because they want it to be easy for people to use their services. Um, so that's oftentimes a concern when people are talking about open source software, right? Hey, who's maintaining it? Well, for many of these cloud native tools and these DevOps tools, um, these companies are directly contributing to the open source code. So AWS is super, super, super simple, right? And it's able to do this because with just like 2 or 4 lines because it'll default that networking infrastructure that I had in a previous example. However, you're probably going to want to specify it. In Azure, we have, right, your name. Oh, so I should say again, okay, the resource, it's, still a virtual machine. It's just written differently for this provider, right? Everything's different in each provider. You give it a name, main, whatever, VM basic, resource group location. Some of this stuff is going to be like resource groups. That's like an Azure thing that if you're only working in AWS, you might be like, okay, I don't think I had to use that before. Yeah, they're very important in Azure, so you're always going to want to kind of be on top of that. Um, but again, instead of your compute type, right? They have a size here, right? But it's still basically the same idea, right? I definitely don't recommend putting your passwords in here. Um, but yeah, they'd like you to create a username and password, um, and you can obfuscate that using tools like Vault, um, or at the very least, your variables. Uh, so definitely don't need to put it in this file like that. Here's your source image, right? So remember we had an AMI image before in the last example, right? And we could just, put quotes around an exact hash number. Well, in here, there's a little bit more. So publisher, canonical, right? It's an Ubuntu server, right? It's got a SKU number, version latest. And for GCP, it's pretty much like that as well, right? So you have another block, you have a boot disk with initialized params, right? You're specifying your image, size, type. And in all of these, you're going to specify what your zone is, right? Because they have data centers on the East Coast, West Coast, in other countries as well. They all have different machine types, right? Compute types. But it's all pretty much the same. So what am I proposing here for how you would use Terraform to deploy to multi-cloud? Well, you would set up your tfconfig files, and then you could use something like HCP Terraform. This is like their SaaS tool, right? Um, to deploy everything to your various clouds, AWS, Azure, GCP, or something else. Um, it might, depending on what your infrastructure is, can't make any promises, but you might be able to even deploy to your on-site hybrid cloud clusters as well. But so why do I stress this here in the middle, this SaaS tooling? Well, because uh, just because you can run Terraform off of your local workstation doesn't mean that you should, for a variety of reasons. For security reasons, uh, through uh, through disaster recovery reasons, and collaborative reasons. You want to be able to have some sort of CI tooling that is running your Terraform, uh, especially for production environments, for enterprise environments. And you want to be able to audit what change was made, who made that change, who deployed that change, when was that change deployed, right? So we're not just so we want to be able to definitely uh, check in all of this, all of our config files into something like Git and have all of that um, auditable um, version control. But we also want that version control on our deployments as well. And so that's why you definitely need to use some sort of a CI tooling to run your Terraform scripts and not be doing it off of your workstation. So now let's take this to the next level. Okay, this is something that if you ask around, probably not even a lot of people knew that you could do. But from my perspective, it only makes sense. So 404, right? App config, application configuration. What do I mean by that? Well, all of us probably use some sort of a SaaS tool. And let me clarify. Just because it's a SaaS tool, I don't want to, maybe I shouldn't say SaaS, right? Because that means software as a service, right? But sometimes you're hosting these solutions in-house. Well, just because you're hosting them in-house doesn't mean that you don't want to leverage configuration as code on those applications. So here I have a screenshot of HCP Terraform, right? And what I am proposing that you do with Terraform is just like you would define all of your resources for your cloud services, you should try to define all of your app configurations as well. So, what workspace am I using, right? What organization am I using? Okay. What users are in there? What security policies am I trying to enforce? Right? All of that stuff can be done in a Terraform script. What does that look like? Well, in this case, right, for HashiCorp's own product, Terraform Cloud, right, you've got a TFE provider. It also used to be called Terraform Enterprise, right? Uh, that's a whole nother story. It's confusing. So you have your provider, right? You can specify your organization. You can specify your workspaces. You can specify things like name and email, right? This is all stuff that you would have to, you know, do in like a ClickOps manner before. And it might be faster to do it in ClickOps. You're like, oh, I'm gonna change the email, from Dan to Kevin to David. It's just faster to do it. But let's think about security. How is the rest of your team gonna know that that change was made? Or retroactively know when was that change made, right? When you're doing it in this infrastructure as code manner, right? Configuration as code manner. Anytime that you hear IAC, just think CAC. Anytime that you think infrastructure as code, just think configuration as code, because that term is that's the goal, and it's more self-explanatory, right? We want all of our configurations for everything defined in code so that we can put it in Git, so that we can have that source control versioning applied to it, right? We'll have disaster recovery, we'll have security, we'll also be able to feed it into CI pipelines so that we can continuously integrate and deploy our changes. So what does that look like in GitLab? Well, if you guys aren't using GitLab or GitHub yet, you should be. Um, if you are already using it, you might be familiar with when you go into settings, geez, there's a ton of settings. There's a lot of settings that always they come out, with all the versions, right? There's more and more settings or whatever, or settings change, and you got to click them and click them. You know, you might only do it once if you're only working by yourself. But in an organization, you have multiple teams, and they're going to have multiple different spaces in this application. And at the very least, you're going to want to copy those configurations over. Well, the best way to make sure that we don't fat finger it and forget about um, what configurations we had for this team versus this team is to get it into code. Here's a little bit of what that looks like. Again, we have our GitLab provider here at the top. We can create a group where we specify the name uh, and a number of other things. You can there's a lot more here I'm not showing you because I'm trying to keep it concise, but you can put all of your security policies in here as well, right? These subgroups here that I have just at the very bottom, right? Those subgroups can be groups of people that you use for security reasons. Okay, first brave question. Would there be a more in-depth workshop with something like this, with hands-on labs? Uh, we could do something like that for you. Um, Honestly, I would probably recommend something like uh, any one of the online Cloud Academy resources or something like that, right? LinkedIn Learning had some stuff. There's Khan Academy. There's, uh, uh, I think there's one called Code Academy. There's Udemy. Udemy's a big one. I like Udemy. I'd probably s- point you to something like that. I personally really like that sort of self-paced learning. Um, it also allows you to uh, just sort of churn over the points that aren't quite sticking. You can sort of churn over them again and again and again until they make sense. Um, and you can move a little bit faster through the stuff that you already understand. Um, Especially with something like Terraform, the easiest way to get into it is to use cloud resources and setting up um, AWS environments for you, right? Like AWS accounts, right? If you have one of those already in your own company, excellent, see if you can get access to it. Um, Although I wouldn't be surprised if they say, well, we're a little bit worried about the spend. Well, again, that's why these online learning resources are really good for that because they've already sort of purchased and set up an infrastructure where they can set up demo environments really easy. Um, and so you can kind of do whatever you want in there because they're ephemeral. They're not going to live long. Um, but it's yeah, I would say the most important thing is about getting those reps in, those repetitions in, create infrastructure, destroy infrastructure. Um, if I were to run a, if I, I don't want to say no, right? WEI is open to doing anything that our customers want, um, ask for. And so we certainly have done that for stuff like VMware, where I think it makes a lot more sense, right? Um, but for Terraform specifically, because it so heavily leverages that cloud infrastructure, I just think it makes the most sense to do those labs is part of like a SaaS-based learning platform. Uh, and that also goes for learning AWS, learning Azure, learning GCP. Um, yeah, when it comes to something like Ansible, it's a lot easier to say, yeah, maybe we can set up an environment for that, right? With physical infrastructure. Because that's oftentimes what the specific experience that we're looking for is. Does that make sense? Why there's a bit of a difference in that I'm not jumping at the idea of doing like a one-time virtual lesson for Terraform or the other cloud providers. Um, but whereas I think it actually might make a little bit more sense to do a virtual lab for like VMware or Ansible. All right. Thank you, everybody. Thanks for attending. Take care.